Okay, in this video we're going to use a Cartesian graph again to draw a polar equation with r is equal to 2 sine x. To do that we need the graph of y is equal to 2 sine theta. Okay, remember that for polar coordinates we need r and theta, where theta is measured from here. These are positive angles up to 180, and around here we go to, sorry, not 180, we should use pi. And then all the way around here to minus pi. Okay, so what we're going to do also in this one, we'll look at what happens when r is negative. Now, before we carry on, this GeoGebra app comes from a GeoGebra book. Okay, and I'm going to put both the link for the GeoGebra book and the particular app that I'm using for this video in the notes of the video. Okay. So we got r is 2 sine theta. So in order to do that, we need to draw the graph of y is equal to 2 sine theta. That's quite straightforward. Sine theta, it's been stretched, and the amplitude just becomes 2. Okay, we're just going to look for positive angles to begin with. So our starting point is here. So if we move along, and if what you've got to remember is that this value here will give you the value here. You can't really see it. Let's make it a bit bigger. There you go, pi by 6. Okay, you can see this line here is 1 here, and it's 1 here. Okay, so what happens is the line's getting, as the angle's going round, this line is getting bigger till we get to this point up here where the line will be 2. As we carry round for positive angles, this line is going to get smaller. We're going to come all the way back round here, and you probably see that we're going to get a circle. This is a circle with center 1 and radius of 1. So the center is 0, 1. Okay, so that is what we get if we do for positive angles. Now, positive angles, if we go back for negative angles, something quite interesting happens here. Okay, so what we notice here, let's take this value here, minus pi by 4. So this is the angle here, you can see minus pi by 4. Now the line doesn't go this way. It goes the opposite way because r is negative. Okay, so here we can see that r is actually going to be negative. Okay, so we need to just remember that when we're sketching. So r will get more negative. Here it will become minus 2. Okay, and then it will come back down, becoming smaller, going the other way on to minus pi, where it will be 0 again. Again, you know, it's repeated itself. We don't actually need all the values to do it. Okay, and so what we can see here is that we have a circle, center 0, 1 with radius 1. Okay, we can very easily come up with the Cartesian equation for this. Okay, so this is what we do when r is negative. So just to finish the video off, I just want to have a look at some other ones that we could look up. So we did a cartesian. This is quite an interesting one. Okay, so this is a 4-leaf rose. Okay, so if we go, so look here, the angle's positive. Okay, here, look, r is negative. So the line goes the other way. Okay, here, still negative, so r is going the negative way to the angle, you see. Okay, and then we're here, it's going to become positive again. So we go out here, and again, it's still positive. We're only doing it until pi. Okay, if we go back the other way, we'll probably get the other part of the shape. Okay, so r will start being positive with the angle. R will be negative, so it's going in the opposite direction here. So you can see it very easily from the curve, until this point here, where it will become positive again. Okay, and we stop there, and we can see here we got a 4-leaf rose. Okay, that's quite an interesting one. We can have an 8-leaf rose as well. Let's just have a quick look at that. It's got more cycles in it, so do it a bit quicker. But you can use the link in the video to try these for yourself. It's a bit difficult to see what dots you'd actually need to join up, but that's what it will look like. Okay, here we've got a lemicon, I think it's called. Okay, and if we slide this down here for this one, if we do this one, we get this sort of shape going that way, and then going the other way, we get that. Okay, and here, don't forget here, in this bit down here, R would be negative. Okay, so that's the curve there. We've done 8. And this is lemniscate. Okay, here we've got 2 values, you see, but they're just going to repeat themselves. Okay, and then going back the other way, they're just going to repeat themselves. Just notice here that one R is going positive, the other R is going negative. Okay, this is not a function, isn't it? Okay, but you get this sort of infinity sign on its side. This is a more advanced one. This didn't have a particular name. Okay, but it gave an interesting shape. Okay, just you know where R is going to be negative. Okay, you go back the other way, you get the other bits of it. So we get quite an interesting sort of flower shape. Okay, here comes another one. Okay, we know where R is going to be negative. You get an interesting shape here again. Okay, and the last one here, we've got a spiral. It's very simple. Y is equal to theta. This is where R is just going to be positive. If we've got R as negative, it's just going to spiral the other way. So we've got a sort of a spiral here. Okay, so we've got quite a lot of curves here that you could have a look at and see how they're formed from their Cartesian graph. Okay, so like I say, the link to the actual circle that I did in this video and the whole GeoGebra book where all these are, I will put in the notes of this video. I hope you've understood and hope you've enjoyed the video, and I hope you find it useful in your studies. Thanks very much for watching.